So today we're going to look at reference angles. Your definition of a reference angle is an acute angle between 0 and 90 degrees, or if you're in radian mode, between 0 and pi over 2. That is between the terminal side of an angle and the x-axis. So what we'd like to look at is a few examples, both in degrees and radians, of how to find those reference angles, because they're very useful in trig, but when you're trying to figure out how to use them, that's great, but you have to first figure out what they are. So, for example, let's look at some angles that are in quadrant 1. All right, so if you have an angle in quadrant 1, all right, we're going to call theta our angle, and say we look at an angle that is 75 degrees. All right, so here's our angle. We again want to sketch it very quickly in standard form. All right, and so 75 degrees is about right here. And so this would be our angle. Right. Now, if you are an angle in quadrant 1, the angle itself is also its reference, because this is the terminal side of the angle, and this is the x-axis. This is the reference angle. So when you're in quadrant 1, because all angles in quadrant 1 are between 0 and 90 already, our reference angle is the angle. Similarly, if you are looking at an angle that is in radian measure, say, pi over 4. Again, we want to be able to sketch really briefly what that angle looks like. And again, you remember that pi over 4 increments. Chop your graph up into 4 equal parts at the top. So this would be the terminal side of my angle, and that is my angle right there. So that's the angle pi over 4. But again, pi over 4 is already between 0 and pi over 2. And so since here's my x-axis and here is my terminal side, this is also the reference angle. So again, we're going to use a little subscript for reference right now and say that our reference is pi over 4. When you're talking about reference angles, if you're in degree measure, you need to have your reference angles also in degree measure. If you are in radian measure, graph is in radian measure, or your reference is in radian measure. Now let's look at some angles that are greater than 90 degrees. So let's look at angles that are in quadrant number 2. All right, so if you are in quadrant 2, say theta is 120 degrees. Again, let's quickly sketch our angle in standard position. And 120 is approximately right here. And so this is my current angle theta. Now, you have to remember a little bit about what the values are in degree measure on the x-axis here. And so the closest x-axis to where my terminal side is 180 degrees. And so because this is my terminal side, this is my x-axis, this small piece right here is considered my reference angle. So it's always between the terminal side and the x-axis, always. So in this case, when I have an angle that is in quadrant 2, to find my reference angle, I'm going to take the closest x-axis value, which is 180 degrees, and subtract whatever theta is. All right? So I want to take 180 minus my angle, and this is going to be my guide. Sorry, that's my guide. And so in this case, specifically, 180 degrees minus 120 degrees means that the reference angle for the one that I'm given is 60 degrees. And again, that has implications as we move on to other aspects of trig. So right now we're just focusing on, I need a guide, something to figure out how am I going to know what that reference angle is for the future. And again, let's say we have theta is 3 pi over 4. Okay, that is also an angle in quadrant 2. And again, remember, denominator of 4 can kind of help me cut this up. And so in terms of radian measures, this would be my angle. And in radian measure, the 180 degrees, or the closest x-axis, is pi. So again, in radian mode, if I'm trying to find my reference, it's going to be pi minus the angle. All right? So you're always using the value that is closest to the x-axis, because again, this is my terminal side, closest x-axis. And something that you can see is that when you have these measures of pi over 4s, 3s, or 6s, again, because I can see I have one increment, I kind of know already what my value is supposed to be. Pi minus 3 pi over 4. I'd have to get a common denominator for here, but my value is going to end up being just a pi over 4 reference. So again, if I have one of these special angles with a denominator of 3, 4, or 6, I can easily see when I'm cutting these up into segments that I'm going to have one of those pi over 4 segments left to get to the x-axis. So I can use my little guide, and I can think about getting common denominators and subtracting fractions, or I can just look at the increment that's left. So things change just slightly when we have an angle in the other two quadrants, but it's very similar. All right, and so if I am in quadrant number 3, right, again, now I need an angle in quadrant 3, so I'm going to say I'm going to let theta be 210 degrees. Right. And again, I want to sketch that. And these should be really quick sketches. Right. And again, this would be 180 degrees, and so 210 is just slightly past that. And that is the current angle that I'm working with. And so my reference angle, again, is going to be from the terminal side to the x-axis. And so it's that little tiny segment right there. Now, since my angle is larger than the x-axis, my guide for figuring out my reference angle is going to be the angle itself minus the 180 degrees. So my angle is a little bit larger than the closest x-axis, so I need to do the subtraction in reverse. I need to go backwards. And so in this case, my angle at 210 degrees means that my reference angle is going to be 30. So again, what are we going to do if theta is in radian measure? Say 4 pi over 3. All right, so let's sketch real quick. Now again, remember with the pi over 3 increments, these ones are a little bit harder because you have to cut them into equal thirds. And so that vertical axis doesn't count. And so if I want 4 of the pi over 3s, that's going to terminate right here. And that's my angle. So again, 1, 2, 3, 4 pi over 3. My closest x-axis and the terminal side makes this my reference. And again, you can see, remember I said if you have a denominator of 4, 3, or 6, I can easily see that I have one increment of pi over 3 in this angle I've drawn in pink. But again, I can think about what that is going to be like as in theta minus pi. And so let's just do the subtraction. So I have 4 pi over 3 minus pi. And again, if I get a common denominator, that's going to be 3 over 3, or a pi over 3 increment as my reference angle. So lastly, we have quadrant number 4. All right. So let's see. We have a theta, and let's use 300 degrees. All right. Let's draw this. All right, and so with 300 degrees, we've gone almost all the way around, and we've stopped right here. And this is my angle. And so when you're in quadrant number 4, because this is your 300-degree marker, you're almost close enough to going all the way around. So your closest x-axis is actually the 360-degree mark. All right. And so again, here's my closest x-axis and the terminal side. I want that little angle right there. So very similarly to what we did in quadrant 2, all right, my guide to finding my reference angle is now going to be my closest x-axis, and my angle is smaller than that, so I'm going to have to subtract off my angle. And so in this case, 360 degrees minus my current angle means that my reference angle is 60 degrees. Right. Again, let's do one in radians. Let's do 11 pi over 6. Right. Draw that out. Now, remember when you are in increments of pi over 6, these need to be cut into 6 equal pieces at the top. And I need 11 of those. All right. So here's pi, or again, this is going to be 6 over 6. And this is 2 pi, which is the same thing as 12 pi over 6, because I have 12 increments. And so 11 pi over 6 is saying going all the way around 11 segments to here. And so my closest x-axis, which is 2 pi, to my terminal side, that's my little angle. So I already know that my reference angle is going to be pi over 6 because I can see I have 1/6 of a segment left. But just as a general guide, again, we can take 2 pi and subtract off our theta. And so our reference angle in this case is 2 pi minus 11 pi over 6. And that gives me 1 of the pi over 6 increments as my reference. And so this is what you want to be able to look at in terms of finding reference angles. Your guides, all right, that you're going to need to use when you are in something other than the first quadrant. So first quadrant, the angle is its reference. But when you are in different quadrants, you need to know how to find those guides to help you out. All right, so I'm highlighting all of the ones that when you're in a different quadrant, what is your guide going to be to help you find the reference angle? You should always try drawing the angle in standard form. All right, it helps you to visualize where you're at. Now, the ones that are going to be a little bit more difficult would be ones if you were going in a negative direction or if you were going more rotations. And in those cases, you're going to want to just figure out, if I were to graph this angle in standard form, what would be its coterminal angle between a 0 and 360 or a 0 and 2 pi to be able to do the subtraction. Because these formulas right here only work if you are in one rotation of the unit circle in a positive direction. So you may have to do a little bit of extra math, but you're really, if I know that I terminate here in quadrant 3, I need to find the distance in this gap. Same thing here. All right, so try to use the skills that you've learned in terms of graphing in standard form, and then these formulas will help you out.